algebra students. I hope you're ready for our last week of distance learning. I know I am. I hope that we all can say hi to each other in person in the halls come September. So we'll keep crossing our fingers for that one. Well, until then, our last topic has to do with measures of center and variation. To get ourselves started here, I have some problems that I would like you to work through to review mean, median, mode. This is not something I'm going to teach. You can see that there is a description of each, a definition on your screen. There is also an example of each problem. So at this time, I would like you to take a minute or two and review this, practice using some of these examples, and then when you come back after pausing, you can check your answers. Okay, here is the answer key. Again, you'll want to pause the video and check your answers. All right, so a new topic for today is called a weighted average, or another phrase we have for this is expected value. And what it is it's a mean that's calculated by using frequencies of data values. A weighted average that you are affected by in your daily life are your grades. We have a weighted average because 70% of your grade is the average of your summative scores, and 30% of your grade is the weighted average of your formative scores. So that's an example of where you would experience this in real life. In order to determine a weighted average, what you would do, if you look at the example on your screen, is we can see that we have movie ratings and then the number of movies that got that rating. So 8 movies had a rating of 4 stars, so we would multiply 8 times 4. 12 movies had a rating of 3 stars, 12 times 3, so on and so on. We'll add up all of those, and then we're going to divide by the total number of movies. So that's where we will add up our 8, 12, 7, 2, and 1 for our weighted average, or our expected value. Another application of this comes with what's called a probability distribution. And what a probability distribution is it will match each outcome with its probability. So that's actually the example we're going to try together. So we're going to find the expected value of prize money in this contest. And notice we're given the probability of getting each dollar value here. Because we are given a probability, we're not going to have to divide at the end, because we know that probability equals what we are interested in over the total. So the division has already occurred. So all we're going to need to do is multiply each probability by its value, and then we'll add them up. All right, so 0 has a probability of 93.59 plus $1 has a probability of 5%, plus $5 has a probability of 0.01. Notice the probability of winning each dollar amount is decreasing as the money increases. That's how prizes are set up. That's how lotteries work. All right, 100. I'm running out of space, so I'm just going to go down below here. 1,000. And when you add up all of those products, what you get is 0.36. And so the expected value of the prize based on the probability is 36 cents. That's what you can expect. Okay, now if you get more than that, that's a bonus. Again, the reason we did not divide at the end, like you saw up here in this example, is because ours had a probability distribution, where this example up here simply had numbers of movies and ratings. Our next topic is a box and whisker plot. Hopefully this is something that you've seen before in your middle school pre-algebra classes or your Algebra 1 classes. And what a box and whisker plot does is it displays the spread of the data. The 5 key points that we use to show the spread of the data are the minimum and maximum, the median, and then something called the first quartile and the third quartile. What the quartiles are is the middle of the lower half, that's your first quartile, and the middle of the upper half is your third quartile. The interquartile range is simply the difference of your quartile 1 and quartile 3. So it's very similar to your range that you learned about before, where you take the minimum and subtract it from the maximum. Here we're going to take the first quartile and subtract it from the third quartile. Here's another picture of a box and whisker plot, or how you would actually create your box and whisker plot. Because a median is required in your box and whisker plot, you always want to list your numbers in order. And then the first thing you want to do is find the median. That will be what you do first. Once you find your median, you are not going to include it when you look at your lower half and your upper half. So now I'm going to look at my lower half of numbers and find the middle of my lower half. That's my first quartile. The middle of my upper half gives me my third quartile. And then at the very end, I can identify my maximum and my minimum. These 5 numbers we call our 5-number summary because it summarizes the data with 5 numbers. Mathematicians are so creative. All right, so we're going to give this a try. We're going to try putting all these things together. Mean, median, mode, range, box and whisker plot, and interquartile range. All right, so first thing you're going to do is find the mean. We'll add up all of the numbers and divide by how many there are. I'm going to let you do that on your own. If you do it correctly, you should get 65.4. Okay. Next thing is median. But what I'm noticing is these numbers are not in order. They always need to be in order before you find your median. So let's take some time and rewrite them in order. So I've got 49 as my smallest, 54, 56, 58, 63, 66, I think I see 2 of those. 68, 69, 71. There are 2 72s, 73, and 79. Looks like I got all of them. Okay, so now I'm going to find the median. The median is the middle number. If I read the situation here, it says that these are the high temperatures for the 2nd and 3rd weeks of May. So I've got 14 numbers here. The middle will be about 7 in there. So what I'm going to do is I'm going to cross out maybe 5 on each side. 2, 3, 4, 5. 1, 2, 3, 4, 5. And then I sometimes will start working in. Oh, I've got 2 in the middle. When I've got 2 in the middle, remember we have to add them together and divide by 2. basically find the mean of these, and then I'll know that my median is 67. You can also probably just tell by looking at the numbers. All right, so median. Mode. Mode is the number or numbers that appear the most. Notice there are 266 and 272s. We have two modes. This is called bimodal. They are both modes. The range is where we take our minimum and our maximum and we subtract them. So let's come over here. Our minimum number is 49. Our maximum is 79. When I subtract those two, I get a range of 30. So I found the mean, median, mode, range. To find my box and whisker plot, or to create that as the directions have asked me to do, I need my 5-number summary, which includes minimum, maximum, median, and my 2 quartiles. So that's the only thing I'm missing right now to make my box and whisker plot. I need to find the first quartile, and I need to find the third quartile, I'm sorry. So notice when I did my crossing out, I crossed them all out the same direction. My first quartile is going to be the middle of this set of numbers. So I'm going to cross out the other way, and it'll help me to keep track. So right here, 58 is my quartile 1. $72 is my third quartile. I now have the information necessary to create my box and whisker plot. I need to draw a number line that goes from 49 to 79 because that's my minimum and maximum. So I'm going to go from 45, I think, to 80. I think I left too much space there. Oh no! Don't erase the whole line. There we go. And it's best practice to draw your box and whisker plot on top of your number line. So I'm going to put points for my 5-number summary. I'll have a point for my 49. And I guess I should use the word above your number line, not on top. Okay. My maximum is at 79. My median is at 67. Quartile 1 is 58. And quartile 3 is at 72. I'm going to first draw my whiskers in from the edges, and then I know the rest of this is a box. I then draw a line just down my box to represent the median. So this is my box and whisker plot. It shows how spread out my data is. I can see that my data is more condensed in this upper quartile of my graph because the whisker is shorter. I can also see, actually it's even more condensed right here in this third quartile area because that looks like that has a shorter distance. My data is more spread out in the first 2 quartiles. Now, the reason I can talk about the spread of the data by looking at how long or short these sections are is because we split the data into quartiles or quarters. 1/4 of my data is in that space. 1/4 of my data is in this space. 1/4 of my data here and 1/4 there. So when I see that it's this big long whisker, I know that the data is really spread out there. But then I can see when I have the shorter whisker, my data has less variance in it and it's closer together. So box and whisker plots are very useful as a quick way to just look at a graph and see how it's spread out. We're not quite done though. We will now need to find our interquartile range. Remember the IQR or interquartile range is Q3 minus Q1. And so the interquartile range of this data is 14. Okay. All right, we're going to take a break right now, and when we come back, we're going to talk more about variance.